Hello, hello, hello. Good morning, everyone. Make a love shout out to subscribers and followers of this channel. And if you are new to my channel, please don't forget to like, share, and subscribe. Today, we're going to study triangle inequality theorem. This for week. Now, students will be able to apply triangle inequality theorem to find missing angles and investigate the measure of segment to determine the existence of triangles or the triangle inequality theorem. And this is your teacher, Marife Adonis. Now, first, we need to identify some of the vocabulary that we are going to identify in this lesson. First, we have a triangle inequality theorem. It states that in any triangle, the total length of any two sides is always greater than the length of the remaining side. Theorem. A theorem is a proposition or statement that has been demonstrated to be true through a logical series of arguments and reasoning grounded in accepted assumptions and previously proven theorems. Okay. So a theorem cannot be proven as true if you approve it. Corollary. A corollary is a statement or proposition that follows directly and easily from a previously proven theorem. It requires minimal additional proof and is considered a direct consequence of the established theorem. Okay, let's now have at triangles or the theorems. We have the side or the angle side relationship in triangles. If two sides of a triangle are not congruent, then the larger angle is opposite the longer side. Okay, so we have this triangle ABC, and this side is the hypotenuse, where AB, okay, is greater than BC. Now, our conclusion, that means measure angle C is greater than the measure of angle A. So this one, the measure of C is greater than the measure of angle A. Okay, so we have a triangle inequality theorem again. It says here, the sum of any two of the sides of a triangle is greater than the third side. So let's see. Now we have a triangle ABC here. Now we could say that AB plus BC, no, is greater than AC. BC plus AC is greater than AB. AC plus AB is greater than BC. Examples. Can these three measures be the side of a triangle? We have 4 feet, 12 feet, and 9 feet. And we have 9 feet, 5 feet, and 15 feet. Now, first thing first, 4 plus 12 is 16, and 16 is greater than 9. So the answer is yes. This can be a triangle. 9 plus 5 is 14, and 14 is less than 15. So that's why no. Okay? Because 9 plus 5 equals only 14. Now, shortcut in using triangle inequality theorem. Tell whether a triangle can have sides with a lengths of 8, 13, and 21. Explain. Let's explain that. The answer is no, because we need to test these numbers using triangle inequality theorem. Add the smallest to the numbers together and see if the sum is larger than a third number. If the sum is larger, then they can make a triangle. If the sum is not larger, then they cannot make a triangle. Now, what about the range of the values for the third side? The length of two sides of triangle AC is 5 centimeter and AB is 8 centimeter. Find the range of possible lengths for the third side, BC. Okay, so we have this triangle ABC. So AC is 5 and AB is 8. Now, let's find the value of. Now, in order to make a triangle X must be greater than 3. X greater than 3. Why? So in order to make a triangle, X must be less than 13. So X less than 13. So why? Combine these inequalities to 3 less than X less than 13. So that means should be like that. Now, in other words, this is what we do to get the answer. Subtract the two numbers, 8 minus 5 equals 3. Add the two given sides as 8 plus 5 equals 13. All right, that's it. Then plug these two numbers into inequality. So therefore, we have 3 less than x less than 13. That is the range of the third side. Okay, let's try this example here. So write yes if the given length can form a triangle, otherwise no if not. So your complete solution. So we have here um, 5 plus 10 equals 15, right? And we could say that the third side is 15. So the answer is no. Why? You cannot form. It should not be um, equal to 15. It should be greater. Like this one, 11 plus 12 equals 23. And 23 is greater than 9. So the answer is yes. Okay, so this is yes. And then 6 plus 9 equals 15. And 15 is less than 16. So the answer here is big no. Okay. And here, 3/4 plus 9/7 equals 21 plus 36. So 21 plus 36 over 28. That's equals to 57 over 28. And here, 57 over 28 is greater than 2/3. So here the answer is yes. Okay. Then 1 plus 15 equals 16. Oh, 15 equals 16. And 16 is equals to 16. So the third side, 16 is no. Big no. Okay. Now let's have another. Use the triangle inequality to complete the table. Two sides of triangle have the following measures. Find the range of the possible measures for the third side. Okay. So just like what we did before, we can do 14 minus 11. That's equals to 3. Then if we are going to add that, 14 plus 11 equals 25. Now, we could say that 3 is less than x and less than 25. So that is the range. All right. Then we have 47 minus 21 equals 626. And if we are going to add that, that's 47 plus 21. That's equals to 60, 68. So we could say that 26 is less than x less than 68. Okay, so that's the range of the value of x. Like we have here 5 minus 8 equals -3. And if we add 5 plus 8 equals 13. Am I correct? Yes, correct. So we could say that -3 is less than x less than 13 when x is less than 13. Right? You may continue for D and E. That's how we get the range. Okay, now let's have this one. Use a triangle inequality to complete the table. Name the largest and the smallest. Now, how do you know from the theorem itself? It says that the measure, the largest side, is the opposite of the largest angle. So here, we are going to name the largest and the smallest. So in here, our answer should be um, angle C. Oh, Y3. Okay, angle C from the largest, no? So angle C, angle B, and angle A. Why? Because, sorry, angle, the opposite, this should be A, and this one should be B. Okay, so here, 8, no? It's the opposite. And angle is 6 and B is 4. Okay, so that's the order. Now in here, we have angle Z, angle X, and angle Y. Okay, that's it. And in here, we have angle P, then angle R, and angle Q. All right, so one. Now, for quiz one, no, you can pause the video and try to find the answer here. That's it. And for quiz two, this one is also. No, you may discover why. All right. Thank you. God bless you.